Hi students, welcome to my lectures on chemical reaction engineering. Today we are going to discuss about the most confusing topics where student will make a lot of mistakes. When to use negative symbol while defining the rate of reaction, and when to use positive symbol while defining the rate of reaction. Because this is the only time you are going to use the negative symbol. And when you talk about the negative symbol and rate of reaction, as you know, in a reaction A gives rise to B. A is my reactant and B is my product. Always the moles or concentration of E is getting reduced with reaction, and moles or concentration of product, which is B, will increase with increasing in time. So whenever we deal with the reactants, we have to use this negative symbol to find out initial and final concentrations after the reaction. And we always use the positive symbol for the products whenever we are trying to find out the initial and final moles or concentrations of the products. And let us, in today's example, we try to find out the concentration of reactant A after the reaction with two different cases. One is by taking positive sign in the rate of reaction, and second example while we take a negative symbol in the rate of reaction. Okay, let us move into the deeper topics. We have to define the rate of reaction or speed of reaction, right? And in homogeneous reactions, in A gives rise to B, I assume there is a homogeneous reaction. In this homogeneous reactions, the rate of reaction Ra minus Ra is equal to minus 1 by V into dNA by dt. This is how we define the rate of or speed of a reaction. What is the volume of the liquid? dNA, or if this volume of the V liquid is in a reactor of volume 1 liter, then volume of the reactor you can take directly. V is the volume of the liquid, Na is the moles of A, and T is the time. A is my reactant here. So whenever I am trying to define the rate with respect to the reactant, I have to use this minus symbol. What is this minus symbol? 1 by V into dNA by dt. dNA by dt, that is change of moles of A with respect to time in V, volume of the liquid. In other words, Na is the moles, T is the time, V is the volume of the liquid. How much moles of A is getting reacted in this a particular reactor of volume V every second? Let me come back. How many moles of A is getting reacted in this 1 meter cube volume reactor every second? So that's what the rate of reaction of A. That means the units will be moles per meter cube per second. If you define the rate in this way, let us solve the example. One with my positive sign of the rate, one is the negative sign of the rate. So let us read through the problem. The rate of reaction in a batch reactor. I am talking about the rate of reaction of A. Okay, A in a batch reactor of volume 1 meter cube is 3 mole per meter cube per second. That means the rate is given. That is 3 moles of A is getting reacted per every 1 meter cube reactor volume every second. Let us find the moles of A remained in the reactor after 30 seconds if the initial moles of A is 3000 moles. Okay, 3000 moles. That means given initial moles of A is 3000 given, the speed or rate of the reaction is given, and time after 30 seconds. Okay, how many moles of A will remain after the reaction? So let us take the rate with a positive sign, because rate will be negative for the reactants. Let us take a positive sign and proceed with the problem and try to find out what is the moles of A remained after the reaction. Let us Ra, I have removed the negative symbols. Ra equal to 1 by V into dNA by dt is equal to 3 is given. That implies 3 is equal to 1 by V into, what is dNA by dt as per derivative? dNA by dt means Na final minus Na initial divided by T final minus T initial. Na final is final moles of A, Na initial I means initial moles of A, T final is the final time, and Ti is the initial time. If you rearrange this equation, Na final is equal to Na initial plus 3 times V into T final minus T initial. I know Na initial is giving 1000 moles, volume of the reactor is 1 meter cube, T final means 30 seconds, T initial means 0 seconds. If I substitute the values and calculate, I have found Na final is equal to 1090 moles, which is incorrect. Why? That means you have taken initially moles of A is 1000. After the reaction, what reactants, what is the final moles of A should be less than the initial moles of A logically, because A is getting reacted. But if you started with 1000 moles of A initial and you have ended up with 1090 moles of A, that means it is showing the other way. Okay, if you take the positive symbol in the rate and try to find out the concentrations, and you are getting more moles of A, which is incorrect. In the same way, if I take a negative symbol in the rate and try to find out, minus Ra is equal to minus 1 by V into dNA by dt is equal to 3. That means 3 equal to minus 1 by V into, expand the derivative, Na final minus Na initial by T final minus T initial. If you do this, Na final is equal to Na initial minus, here minus symbol comes, 3 times V into T final minus T initial. If I substitute all the values and I calculate, Na final is equal to 910 moles, which is correct, because I have started with 1000 moles of A and after 30 seconds of reaction I am expecting only 910 moles of A is remained. What happens? 90 moles of A getting reacted after 30 seconds. During this 30 seconds, that means which is correct. So now you have understood why taking negative sign is important for the reactants. Okay. So I hope you have learned something. Let us come with the new lecture. Thank you very much.